Thanks for joining me in today's lesson. In this first tutorial, we will use the fundamental counting principle. And we are in combinatorics, sections 10.1 and 10.2 in our textbook. And I'd like to start actually with our final question of the lesson, try 2. It says, which would offer more choices? A license plate that has 3 different letters in any order, or 5 different non-zero digits in any order. Why don't you pause the video right now and think about this try question. Which do you think would offer more license plate choices? Pause now. So hopefully you've made your choice. I don't know if you've chosen A or if you've chosen B. We're going to find it out at the end of this lesson which one of these offers more choices. So this tutorial is going to talk about the fundamental counting principle. I like to use this as often as I can. And what that says is if we have a certain event, I'm just going to call that event E sub 1, and it can occur a certain number of ways. I'll just call that M sub 1 number of ways. And we have another event, and I'll call that second event E sub 2, and it can occur a certain number of ways. Let's just call that M sub 2. Then the number of ways that both of these two events, E sub 1 and E sub 2, can occur is found by taking the number of ways that one of them can occur and multiplying that to the number of ways that the second one can occur. And that's really it. That's the fundamental counting principle. To figure out the number of ways that multiple events can occur, take the number of ways that each event can occur and multiply them all together. For example, in example 1, I want to roll a die, pick a card from a standard deck, and flip a coin. It says how many total ways could this happen? Well, first let's figure out how many events are happening. There are 3 events: rolling a die, and picking a card, and flipping a coin. 3 different events. How many different ways can you roll a die? Well, there are 6 sides to any cube, and a die is a cube, so there are 6 ways that you could roll a die. Pick a card from a standard deck. Now, if you don't know much about our standard deck of cards, that's fine. You can always ask me a question about a standard deck of cards, and I will tell you about that. But there are 52 cards in a standard deck. So to pick one of them means that there's 52 ways that I could do that. I could pick an ace, or I could pick an 8, or I could pick the 6 of clubs, so on and so forth. So there are 52 ways that that event can occur. And last event, flip a coin. Of course, there's only 2 ways to flip a coin, heads or tails. So we found the number of ways that each one of these events can occur. All we have to do is multiply them together, and we have 624 different ways that these events could all occur at once. For example, I could roll a 6, pick the ace of spades, and flip a head. That's one of the 624. Or I could roll a 6, pick the ace of spade, and flip a tail. That's another one of the 624 ways. So there's 624 total ways, and all we had to do is find the number of events and how many ways each event could occur, multiply them together. Let's look at example 2. Example 2 is dealing with our license plates. It says that the standard configuration for a Virginia license plate is 3 letters followed by 4 numbers. And here's a little picture of a nice little Virginia license plate. A, it says, how many possible license plates are available in this configuration? Okay, so again, 3 letters followed by 4 numbers. How many events is that? There are actually 7 events. There's picking the first letter, picking the second letter, and picking the third letter, and then 4 more events: picking the first number, picking the second number, picking the third number, and picking the fourth number. I just like to put a little blank for each of my events. Now we need to figure out how many ways each of these events can occur. Well, to pick a letter, we know that there are 26 letters in our alphabet, so there's 26 ways to pick a letter, and there's 26 ways to pick a second letter, and there's 26 ways to pick a third letter. So 26 times 26 times 26. How many ways can we pick a number? Well, there are 10 total digits, just for the same reason that we have 10 fingers on our hands, because that's how we used to count. There are 10 digits, 0 and then 1 through 9. So there are 10 ways to pick the first number and 10 ways to pick the second number and the third number and the fourth number. Multiplying all of these numbers together will give us how many possible Virginia license plates we can have. And that is 175 million. You're just plugging that in the calculator. 760,000 license plates. Okay. So now let's start to put some restrictions on this. Part B says, how many possible license plates are available if the letters cannot be repeated? Okay, it's still 7 events. It's still picking a first letter, picking a second letter, picking a third letter, picking each of the 4 numbers. There's still 7 events, but if the letters cannot repeat, let's figure out how many ways these events can occur. Well, picking the first letter, there's still 26 ways. We have to pick a letter. But once we pick that letter, we can't use it again. So there's only 25 ways to pick the second letter. And once we've picked the first one and the second one, we cannot use those 2 letters again, at least according to the rules in this problem. So there's only 24 more letters to pick for the third one. It doesn't say anything about my numbers, so I can continue to pick any one of our 10 digits, multiply all these numbers together. Obviously, we're going to get a number that's less than what we just had. We have 156 million. With such large numbers, of course, we're putting our commas. Anything that's larger than 4 digits, we will always put commas. So I'd like you to pause the video right here and do try 1. Try 1 says how many possible license plates are available if both the letters and the numbers cannot be repeated. Why don't you pause right now and go ahead and get that number for me. So thanks for trying this problem, and I hope that you got the correct answer. If we are not able to repeat the letters, then it's the same as what we did in part B, 26 ways to pick the first one, 25, and 24 ways to pick the second and third ones. If we're also not allowed to repeat the numbers, then yes, we have 10 possibilities to pick the first one. It could be any of our 10 digits, 0 through 9, but then once we've picked one of them, there's only 9 options to pick the second one. And once we've picked those 2, then there's only 8 options left, and then 7 options left. Multiplying all 7 of these events together, we get 78,624,000. Great. Let's continue working with the fundamental counting principle. Example 3 says 10 students are competing in the Parkview Talent Show. Part A says how many ways can these 10 contestants place, assuming that nobody is going to tie? So if we're using our fundamental counting principle, we need to know how many events we have. So how many ways can these 10 contestants place? Well, there are 10 total events then. Picking a first place, picking a second place, picking a third place, all the way down to picking a ninth place and then picking a last place. So there are 10 events. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different ways. 10 different events. So picking first place, well, there are 10 total ways to pick first place. One of the 10 has to win, hopefully. But once you've picked first place, how many ways can you pick second place? Well, there's only 9 contestants left. One of them will win second place. And then there's only 8 contestants left. And then only 7. And then there's only 6. And then there's only 5. And then there's only 4. And then there are only 3. And then there are only 2 contestants left. And the last event, which is picking the person who comes in last, well, once you've placed the first 9 people, there's only 1 person left. So each of these is going to be multiplied together, and this will be how many different ways the 10 students could place in this talent show. And that is 3,628,800. That is a lot of different ways. Word problems should end in words. A lot of different ways that could happen. So part B, now usually when we're talking about a talent contest, we're not very interested in the people who get 7th place and 8th place and things like that. Usually we're just interested in first place, second place, and third place. So part B says how many ways can the top 3 place? Well, this time there's only 3 events, picking first place, picking second place, and picking third place. How many ways can we pick first place? Well, if there are 10 total contestants, then there are 10 ways for somebody to get first place. It has to be one of the 10. But then second place, again, there's only 9 people left to get second place, and there's only 8 people left to get third place. Since we're just talking about the top 3 places, it's those 3 events multiplied together, and there'd be 720 ways in this case. A little bit more manageable, I guess. 720 different ways. So that's it for this tutorial on the fundamental counting principle. Thanks for watching. I'll see you in the next tutorial. Bye-bye.